Thank you for joining us today. So today I am excited to show you a fun project that can easily make from home. It's called an automated watering system. So what's so special about this project? It actually uses embedded system. We call it as IDE, and this means that it actually can water the plant by its own. So here are the items and components that we need for this project. So here is the Arduino Ide board with the cable attached, and also the breadboard. And we will need 3 of this female to male wires, and also a moisture sensor, and a comparator, as well as our submersible motor pump that attached to a transparent pipe, a connector which has like 2 push buttons, 5 wires of male to male, and some recycled materials for cardboards and plastic bottles, as well as a power bank. Alright, so let's get started with the wiring of this prototype. First, we power up the breadboard by connecting the GND and the 5V pin from the Arduino. So what is a 5V? 5V actually represents a positive terminal, while GND is what we call the negative terminal. So you will need these both to create a loop containing both positive and negative for electricity to go through. An easy way for you to remember this by looking at any AA batteries. You will see that it will always have a positive and negative for it to work. So this is how you power it up, by grabbing 2 wires of female to female wire, and that's how a 5V connect. Another wire would be for GND. Alright, so next we move on to the moisture sensor. So this is how moisture sensor look like, which you can see here there's 2 probes. This allows for current to go through water, and also it produces a value that can measure a moisture content water. So let's grab this end of this wire to connect this comparator right here with these 2 legs. Like that. And moving on to the comparator. As you can see, there are 4 pins from this comparator, and this comparator actually executes the signal from a moisture sensor to the motor. So we will only be using 3 legs of this comparator. So let's get a female male wire, looks like this, for the first leg of the comparator, which is labeled as VCC. And this connects to the 5V right there. So the second wire of female to male wire connects the second leg of the comparator, which labeled as the GND, and obviously this will connect to the GND of the Arduino. And the last one, the last leg, which labeled as A0 of the comparator, connects to the A0 pin on the Arduino. That's how it looks like. Alright, so moving on to, now let's move on to the pump. As you can see here, there's this is a small water motor pump that can move fluid water through this transparent pipe. So you can actually easily get this from online, like Citron and Shopee. So do take note that this black wire of this pump represents the negative terminal, whereas the red wire represents the positive terminal. So let's grab the connector, a quick connector right here. It looks like this, to connect these two wires in by pushing this button down. And it looks like that. And grab another 2 female wires to connect the other side of the connector. And there how it looks like. Next, so this yellow wire that connects to the black wire of this pump will connect to the GND of Arduino. And the other wire will connect to digital pin number 9. So this is how it looks like. Alright. And there you have it. Alright, so now that we have the hardware bit sorted, let's move on to the coding. So before we get started, let's understand what this software is all about. So basically, Arduino IDE is an open source software that is used to write the computer code and upload it to the physical Arduino Uno board. In simple terms, it's the IDE that gives instructions from the computer and tells your Arduino what to do. It's kind of like a recipe for a cake that you bake. So don't worry, if you don't have this software, you can easily download it from the Arduino IDE website from here, and go to these download options and choose your operating system. From here, you should realize that we are doing a combination of computer hardware and software designed for a specific function known as an embedded system. We want to program this prototype to switch on the pump only when it detects dry soil, and will turn the pump off when it detects moisture in the soil. As simple as that. Now let's do some coding. So here's the interface of the software. Let's create 3 variables needed for this prototype project. So the first variable would be the sensor pin. And the second variable will be the sensor value. The third variable will be set as the limit value, which is 400. So as you can see here, I'm using an int variable, which is short for integer. This variable holds a whole number, and the first variable sets define A0 as the soil moisture sensor, and the second variable stores the output of the sensor, and the third variable sets the limit of the moisture in the soil. Moving on to the void setup function. So let's start with the serial begin with the default number of 9600, and next will be the pin mode. So this serial begin, oops, sorry for a typo. So this serial begin actually starts the serial communication, and the pin mode sets a specified pin, which is pin number 9, to behave it as output. Then we will move on to the main coding right here, which is the void loop function. Let's start with the sensor value, which we have declared in the variable. Second one will be the serial print. And the third one will be the serial print for the sensor value. And then we will continue with an if-else condition. And the else condition, don't forget. And last one will be the delay with a default number of 1000. Don't forget your semicolons, and you're good to go. That's it. So I'm done with the coding. I should put upload, right? Like press the upload button. Okay.
Okay, you can
continue.
Start.
Okay. So then we will, after done with the coding, you can click the upload button right here and save this file as moisture sensor. And looks like there's a error when it's uploaded. As you can see, I have not declared the sensor value. Oh, okay, so there's a bit of typo right here. Let's fix that up and click upload again if you have solved the errors in the coding. That's pretty normal, don't worry guys. Oh, okay, so apparently there's an error occurred while uploading. It's because I'm not connected to the Arduino board yet. So don't worry. So once you guys upload this coding in, make sure you connect your Arduino board cable to your laptop. So that's it from the coding. Thank you guys. So here's my favorite part of building this project, because this is the part where we can be more creative. So this is not only fun to do, but it's also environmentally friendly. As you can see, we'll be using the recycled materials, and you will need scissor and sellotape for this project. So this cardboard is actually for the storage of the components used in this project, and these plastic bottles will be for your water pump. Alright, so here how does it look like for the final product of this prototype. So here is the storage of all of the components used in this project. The Arduino board, it's in here, and this is where the water pump is in this plastic bottle. And here is the plant with the soil in, a dry soil. And of course, in order to power up your Arduino board, you will need a power bank, which you'll be using the same cable that uploaded in your coding to the board. So after the uploading the code, you can plug the power bank in, alright, and see how this demonstrates. So here is the final product of this project. As you can see, here is the storage of all of the components used, where the Arduino board is, and this is the storage for the water pump in this plastic bottle, and also your plant with a dry soil. So you will need a power bank to power up the Arduino board. So after you have uploaded the coding in the Arduino board, you will use the same cable and plug it to your power bank. So let's plug it in and start with a demonstration. I've switched it on, and this is the moisture sensor, which detects the moisture in the soil. So let's plug that in this dry soil. Make sure it's covered in the soil, and I'll add this water in for the water pump to work. So if it's a dry soil, the water pump should be switched on. We should switch it back in. And it's okay, it won't have you might take a while for it to switch on the pump due to the water pressure. As you can see, there's water flowing, and it means it works. And water is flowing in the soil, where the soil would be wet. Once the soil is wet, it will switch off the pump. There you have it. No more flowing of the water from the pump. Alright, so this is what we call the automated watering system with IDE prototype. Hope you have enjoyed learning the coding as much as I do. And this is definitely a fantastic DIY work which can be done by anyone, especially for families, for friends. You guys can do this easily during the school break. So if you guys need any help, you guys can contact us. And alright, so that's it from me. Thank you for tuning in, and hope you have fun trying this out. And thank you, and stay safe, everyone. Alright.